LUKS, or Linux Unified Key Setup, is a partition encryption system. Encrypted file systems are extremely useful in ensuring that the data stored on a user's laptop or removable device, such as a USB key, will be safe in the event that it is lost or stolen. The RHCSA exam objectives specify the ability to create a LUKS encrypted partition and to have it prompt for a password at boot, so that is the example that we are demonstrating here. Do not attempt to encrypt a file system that already has data on it, as you will lose all of the data on that partition. If you wish to encrypt a partition, be sure to back up all data on that partition beforehand. We have already created a new partition that contains no data to show you how this is done. We will be using a brand new /dev/sdb1 disk. To encrypt our partition, we run the crypt setup command. We are warned that we will lose any data that may be on this device. Since this is a new partition, we will continue on and type in yes. We then enter a passphrase for LUKS. And we see that the command has completed. Next, we can open our new encrypted partition with crypt setup and the LUKS open option. The last part of the command, the word safe, is there to give a name to the partition after we open it. We can verify that our new device was opened by checking in the /dev/mapper directory for our encrypted partition named safe. Next, we can create a file system inside our new encrypted partition. Now, let's create a new directory to mount our encrypted partition to. Now, we will mount our encrypted partition to this directory. Next, we need to relabel our SC-Linux security context on this new directory with the restorecon command. In order for our encrypted partition to be brought up at boot, we need to edit the /etc/crypt tab file and add an entry for our partition. The first field is the name that we give our device, just like what we did when we opened our device. When the system boots, it will show up as /dev/mapper/safe. The next field is our encrypted device, and the final field is for our password to decrypt our partition. By entering in none, we are forcing the user to enter in the password to decrypt the partition. We could enter in a directory that contains a key file instead. Read the man page for the crypt tab file for more information on how to do that. We also need to modify our /etc/fs tab file to add an entry for this partition to be brought up at boot time. Now we are going to reboot our system, and we should get prompted for a password so that the system can open our encrypted partition. And here we see that we are getting prompted for the password. So we enter in the password and press enter. And the boot process should continue. Now let's verify that we have our safe partition mounted. And there it is. We can check the status of our encrypted partitions with the crypt setup status command. And then give it the name of the device. Take a look at the man pages for both crypt tab and the crypt setup command to learn more about setting up encrypted partitions.